Hello, everyone. Thank you for coming today. Happy reInvent. And thank you for spending an hour out of your busy conference schedule with us to talk about and reflect on what I think is an extremely important thing that we all do, no matter what role we're in, which is operational excellence. For the next hour, Colm and I'm David, we'll be sharing stories from our time at Amazon, operating the services that you all use, from DynamoDB to Route 53 and a whole bunch of other stuff over the years between the two of us. So we'll be going through 4 stories, kind of starting from event management and what it's like to be on a conference call trying to mitigate some impact in real time very quickly. Also, we'll talk about deploying infrastructure and deploying software, two related but different things. And then we'll talk about a heavy lift of changing something which really cannot be changed. You're up.
So David and I have both been at Amazon a while, and we're both members of the Call Leader program at Amazon. And so we play a role in if there's an operational incident, we're behind the scenes helping coordinate and manage that event. We call those kinds of things events, by the way. Other folks call it incidents. I've heard other terms around, but we've just always used event. Makes it sound more like a party. But I've learned a lot on those events, even though maybe there's an issue and something might be down. It can be this amazing opportunity to learn from others and figure out how things really work, or very effective processes at getting things back. Not all of the events that we manage are things that impact customers. They're not all outages or issues like that. We use the same event management process for what we call game days, which are simulated events or drills. So actually, every time we build a new AWS region, before we launch it, typically a few times these days, we'll use that full region footprint infrastructure as kind of a test location where we'll just simulate some issues. What would happen if power failed in an availability zone, or if a certain network link died, or something like that. And then see how we respond, learn as many lessons as we can, and so on. In an event that's not impacting anybody, that's the happiest way to learn those lessons. But we also have events when systems are in a degraded state. So for example, if we lose live electrical power from the grid, that's not going to be an outage because we've got UPSs and battery backups and so on. But we're in a degraded state, and there'll be a call running, and we'll be making sure that we don't do anything else that might make things worse, or could increase the risk. We also use the process for things like peak sale events, and then very, very occasionally for security response. And typically that's things like Log4j last year, where many teams at Amazon and at AWS had to do updates and upgrades to make sure that there wouldn't be any issues with Log4j security events or anything like that. And that all had to be coordinated. And so we reuse our event process for like that. And again, that's an example where there's no customer impact. We've had some kind of event management process for at least 25 years at Amazon. It goes all the way back to when we were much smaller, just selling books. And anything that could prevent us from selling books in real time would spin up our event management processes. There's no one right way to do it, but the way we do it is that we use audio conference calls as our primary means of communication. We're literally on an audio conference call together, talking to each other synchronously in real time, and a ticket, a tracking ticket where we post updates and we track, what have we done when, what are we seeing. A lot of that is for, back reference when we go to do, post-incident analysis. We want to be able to see what happened when and how well we did and how we can improve for next time and so on. We do use chat as a secondary communication mechanism. We use Slack, and we have our own Chime system and Wicker, and we use all of those in different ways, and different teams use different ones. We used to use IRC, but that's not so common anymore, unfortunately, in my opinion. But not many people come in knowing how to use IRC anymore, so it's kind of gone by the way. And these calls are led by dedicated call leaders, like myself and David are examples. And that person, as long as that event is running, is essentially, like, in a sense, the most senior person in the entire company. They outrank everybody. They can make any decision needed. They can make things happen. And we also have facilitators on the call from our safety engineering team, and those facilitators are helping us with the ticket management, or if we need to engage others, paging people and so on. So we split those functions. And then we split things in another way, just to keep things a bit more smooth. We have a dedicated call that's 100% focused on, fixing the issue, right? The technical resolution. And we actually have a separate call for customer communication. And typically on the technical call, it's mostly engineers and engineering leaders who are working on fixing the system. And on the communications call, it tends to be executives, and sometimes account teams and so on, where we're doing bi-directional customer communication, trying to gather as much information as possible and what customers are seeing so that we can prioritize what to do, and also writing those status dashboard updates that go up. But those things are kept very deliberately separate. One side effect of that is on the technical call, because we're not prioritizing for that communication, it can be a bit laggy by the time the folks who are on the communications call can tell what's going on. And so these technical calls, they can have a small number of people on them. If you've got an issue in some subcomponent or service that's got a clear boundary around it, you'll typically only have the call leader or facilitator and maybe members of that team there, and they're just working it away. Or it can be quite broad. If it's an event at a very low level or that impacts several systems, there can be hundreds of people on this call, and so it takes deliberate management to keep things running smoothly. And we have a framework that we boil things down to and put it in our training to remind people, how to be effective on these calls. And it's the SAFE framework. And the kind of biggest and most important thing that we tell everybody is, you have to maintain urgency. These events, it's critical that we resolve them as soon as possible. We're not going to be relaxed about how we deal with these issues. But panicking does absolutely no good, and cool heads always prevail. And I think if you join one of these calls, if you were able to listen in, you'd hear that the experienced leaders are they're pretty calm and smooth, and that has a network effect and kind of influences everybody else. If folks bring a chaotic or a frenetic energy, which can be very natural human tendency, if something's down, that can be a stressful event, and it's a big part of our job to just help them see things clearly and calm things down. We have a big mix of experience level on these calls. The call leaders and facilitators, they're pretty experienced, been doing this a long time. They've probably been on many calls. But most of the other people, if you're just a member of an average AWS team, you might be on one call every few years, right? And many people who are joining, they've never been on one of these calls. That's a really good thing, right? We want that. We don't want people to become experienced at these calls, because that would mean we're having a lot of outages. Like, that's not the right thing to optimize for. But it does mean we have to be able to be very deliberate and considered with those folks and help them manage the situation as well as possible. The next thing we ask of people is be an active participant. You got to be assessing everything. You got to be able to listen to the summaries that are happening periodically on the call and stay abreast of those. And you've got to be able to provide summaries to the call of your area, if you're called upon, right? So you're not just sitting there listening in. At a minimum, you're looking at your metrics and your dashboards and gathering information in real time and so on. Scanning for unknown customer impact or anything we don't seem aware of is very critical. We'll always let someone interrupt and pipe in if they see that, because that might be our next priority. And also, if we're resolving an issue, we want to be able to confirm that the resolution is actually happening, right? And that means people need to actually pay attention and confirm those things. The next thing, I think, is probably the most important thing that we do on calls, and it's a little different than I've seen advice elsewhere, which is most engineers, if there is something broken, and by most, I mean 99.9%, including me before I really learned this, will have a very natural tendency to figure out why it is broken. They'll just go straight into root cause analysis. But we don't care why it's broken. That doesn't matter. Right? We just want to bring it back. Now, if we have to figure out why it's broken to bring it back, we will, but most times you don't, right? Most times you can restore service by rolling back recent changes or flipping from a primary to a secondary. There's a list of actions that we try to prioritize and fully exhaust or before we start doing root cause analysis. Because our experience is if you just focus on those things, you'll fix it. You might not understand why you fixed it, but you can figure that out later. That's what our post-incident process is there for. A great way of summarizing this is, if a patient comes to a hospital bleeding, first stop the bleeding. Doesn't matter why they're bleeding, right? You want to treat them first, and then figure it out. And then the last thing we remind everyone of is, again, it's a natural human tendency, but people want to be self-sufficient. They want to be able to, if they get paged for an incident, they don't want to have to bug somebody else about it. So we have to remind people and remind ourselves, if this issue looks like it's going to go on a while, or if it looks like it could be broad, or it's outside your area of immediate expertise, pull in your principal engineer, or your manager, or whoever it takes, your secondary. Have as many hands at the keyboard as possible, because our experience too is that that can speed up resolution. These escalations are really, really important, and something we drill into our culture too is to be grateful for escalations. Even if I'm paged at 4 in the morning and it's an inconvenience, I'll generally thank the person who paged me. So just want to give one example event to kind of put a bow around this, because it's one of my events that I learned a lot from. It was an event we had in July 29th, 2016. It wasn't a big event, right? That's probably not a date you've ever really seen mentioned or anything like that. But it impacted a number of things at the same time. The Amazon EC2 API that's used to launch instances. Now, running instances were fine, but launching a new one, that was interrupted for a while. Amazon Prime Video and parts of Amazon.com. Right? Amazon.com mostly worked, but some parts of it didn't. There were some items you couldn't buy or whatever. But this was on a Friday night, which is one of the busiest time periods for Prime Video. People like to watch movies on a Friday night. This issue, the underlying root cause turned out to be a change in SSL configuration layers and very low levels in our system, actually old kind of legacy hardware load balancers, things that we no longer use. But it was a very hard to understand issue, and then it impacted these broad things, which were in very different parts of the company. Amazon.com, Prime Video, and AWS, they're whole different kind of macro organizations at Amazon, just the way we're organized. And we all had to pull together, and we all had to work together to get this event across the line and make sure that we would restore service. And our processes kicked in, worked kind of the way I'm describing. And even though these were different parts of the company who are ordinarily, never really on the same calls, the processes still worked, and we had clear boundaries, and we were able to restore service. And in that case, we restored service by rolling back changes until things started working again. And it's just an example of how just having these abstract high-level processes can really help no matter what the cause is or no matter what the event is. And I just think they're worth applying in any organization. And with that, I'm going to hand things back to David.
Great. So one aspect of operations that we all do on the systems that we work on is that we make changes to them. We're all going to fix some bug, we're going to patch something, implement a feature, security patch, we're going to change something to make it scale better or something, whatever. But every change we introduces some risk that it might not work. So after all, every bug that you fixed in production was deployed to production. So what better way to do is to stop it before it even reaches there. So this is all about a story about deployment safety. And actually, we found that the safest kind of deployments are automated deployments by taking humans out of the loop as much as possible. So let's talk about a story of how we started doing that at Amazon. So let's rewind the clock to Amazon.com. This is an artist's rendition of what the website looked like at the time. It's actually I loved the user interface of Amazon.com at this time. It was actually in textbooks that I read for like human-computer interaction, like these tabs that like put parts of the site in front of the other. Super innovative. It's really neat. Anyway, this is what it looked like. And so around then, this is what the architecture also looked like. So we had a web server fleet running a big C++ binary that did all the web rendering. We had our own kind of language for expressing HTML, like template rendering, and that got compiled into C++. And then it all talked to there was like a handful of databases, big databases that handled had all of the product information, all your like shopping cart information, everything in there. And just to show just kind of then how big this got, well, it was slowing us down and kind of got in our way because the website itself, that C++ binary, had grown so big with so many developers all contributing code to it, checking in and growing the code base, that we could no longer link the binary. The linker was like, it's too big. And so we actually had a really big bottleneck in our way as a result. Now, this isn't a story about that technology problem. We just fixed the linker thing and got past it. This is actually a human problem. This is a story about coordination. So because this was one web server environment, it all had to be built, compiled, built, linked, and then deployed all together. That also meant we had to test it all together and everything like that. One kind of release train, kind of a deployment train kind of called in. I was on the team that helped manage that, keep that train moving. Well, the thing is, we were growing as a company with more and more developers all checking code in. And so, every couple times a week, the train would leave the station with more and more of a bundle of change as a result. And so there was more and more that teams had to validate and revalidate. And any change anybody makes has some probability, some non-zero probability of having a problem. And we'll catch it in testing, hopefully. And then if we notice something in testing, that means we have to pause the train and keep it from moving forward until we can get that patched in, and then the train can proceed. But the problem is, while we're waiting for that, while there's that time when, okay, now the train isn't moving, but somebody has something really urgent that they needed to get out on the second train that week, but now we're already kind of halfway through that week, and can I just sneak that one little change in? Well, with more and more people, there were more and more of those kind of emergent changes coming in, which also had a non-zero, maybe greater probability of breaking and then pausing the train even more. And at one point, instead of twice a week, I think it took us a month to get one release candidate out, and we're like, okay, this is a bit wild. So what do we do about it? I'm kind of like combining a few stories together, but around the same time, we decided that we were going to kind of refactor our whole architecture into a service-oriented architecture. All that coordination that was happening between teams, well, how better to remove that coordination and communication by just having each team own an actual hardened API that's a separate service entirely. And so we kind of moved some of the business logic outside of the presentation layer into services and that sort of thing. And this helped us a lot. It helped us innovate and scale and choose different kind of technologies for different parts of the architecture differently. Longer story about this is in this blog post that Werner posted recently called we called the Distributed Computing Manifesto. And so it's an interesting blog to check out later. But now that teams are kind of decomposed, they all have their own separate release train. So I had worked on the tooling that was making that one train go. Now everybody had their own deployment train, and they had to figure that out on their own. And what that meant is now each team, instead of just say me having to deal with this, each team had to kind of shepherd their own release process through. They had to say, oh, okay, did I do my tests yet? Okay, now I need to deploy to the next staging environment. Okay, now I need to do this and deploy to the next region. It was now teams kind of were left to their own devices to have to do that. And so we got ahead of this with automation. Okay, now we don't want people to have to waste their time and relearn everything. So I can kind of take my tool and make it so that other people can use it to nudge things along. But it wasn't really a complete solution. It was just automating each of maybe partial steps and everything. People still had to think about it and get it right and still had to do work. And so we realized that there was just all this kind of burnt time going on and effort. It was actually, and we looked across the company and saw that we were spending so much time on it with so many teams with their own pipelines that every change was delayed from check-in to first production environment deployment was on average 14 days. So that just represents all this like missed opportunity to get features in front of customers faster, bugs fixed faster, and just it also was sort of like symbolic of all of that human work that was going on behind the scenes just to keep things moving along. So what did we do? Well, we made a North Star as a company. We took this overall goal and said, you know what, it'll be better for a lot of reasons if we just really automate this stuff. So we built a deployment pipeline system that everybody could just model their kind of environments and releases and everything like that in this tool. In the same tool, everybody would register their own. And it would handle just kind of pushing things along, letting like the code flow and just holistically automate. Instead of just thinking step by step, it would do it all end to end. And doing this, when the kind of flagship team adopted this tool, they saw a 90% reduction in that time from check-in to production. So fantastic, and we have since adopted it everywhere across. So this movement to this central deployment system did a lot more, though, than just keep the code flowing. It actually helped us in a lot of other interesting ways. So whenever we have a deployment failure, any operational incident at all, including a deployment issue, we write what's called a COE, a correction of error. You all call these, everybody calls them different things, root cause analysis, retrospective, postmortem, whatever. So we all write these, but at Amazon, we all write them in the exact same way. We write them, first we start with a summary, and the summary can be read by anyone at Amazon. I mean, it can be understood, you can read the whole thing, but it can be understood by anyone at Amazon. And the thing is, if we're going to spend all this time digging in to figure out what happened and how to prevent it from ever happening again for us, I would love it if everybody read that so that they could also not have that happen to them without having to have it happen to them and then learn it. So we write these for anybody to understand. So the summary is just in really like kind of it takes you from the high level, what is this thing even for, to what happened. Then we talk about the customer impact. And this is a really important section to kind of quantify of, well, what really did customers see? What did their applications see? Because as like Colm was saying, what we're really trying to optimize for especially is preventing that customer impact. We'd rather have this and none of you even notice than like have it maybe like we just want to make sure we focus on minimizing that customer impact in anything. So we quantify that well. And then we start with this kind of section that really gets into it, the whys, the 5 whys, which are really just a lot more than 5, because we say, well, why did this happen? And then you kind of partially answer it. And that leads to more questions, like, well, why did that thing happen? And then you partially answer it, and you keep going until you get to, and they often they branch off, and you have different sections of questioning. And so it's really a useful tool to just keep making sure we get the ground on this. And out of those whys come action items and lessons and everything that we then track to make sure we address. Now, the other thing that's really important, I think, about how we do these retrospectives is we have them all in one library, like the whole collection of them. And we can look at them over time and just really examine them. And one way that we kind of mine that library, it's really a gold mine for that pipelines team. The team who makes that deployment system, they love this because they can examine every single outage or incident or event that was related to a deployment. And they can say, now it wasn't the pipelines system causing it, but they can look at it and say, okay, if this deployment from this team triggered the event, how can I make the pipelines tool prevent that from happening in any deployment? So they can really like examine these and improve that tool to have all better guardrails and better practices. And because everyone's using the same deployment system with every step modeled, they can programmatically query and audit all the pipelines in the company to see which ones, like, okay, we learned a new practice. Let's go figure out which teams we need to inform to adopt the new practice. We can even stop them from being able to deploy unless they see that they have to fix this thing. So having this centralized deployment system that everybody uses independently, so you have all these separate trains leaving the station. I guess they're separate pipes now. Kind of switched that. But anyway, we find this leverage because we can examine and look for patterns and make things safer, and then we can also just programmatically make everybody's pipeline safer. Oftentimes we don't even have to have people adopt new practices, we just can change the pipelines by default to follow that new practice. across everywhere. So pretty nice. Okay, so that's kind of the story, but what are the categories, what are the actual lessons that we've learned over time? Well, there are a few types, and so these are kind of described in some of these links I'm leaving here, are links to the Amazon Builders Library. We have a bunch of more detail about all these. I think there's a QR code at the end. So the first category of safe practices we found is good pre-validation. So before the deployment even gets to production is the best time to prevent it from to prevent any kind of impact. And so things like code review, we got to make sure we have like the right people doing that code review, doing thorough code reviews to look for, okay, you've written the code, but have you actually put the right instrumentation and alarms and metrics and everything in place to operate this thing? Are we using secure library dependencies that are all up to date? All these kind of pre-checks, integration tests, rollback tests, load tests, game days. Some teams actually a lot of teams do game days as part of the deployment automated in their own environment, test environments. So all that stuff, and while all this stuff is flowing through the pre-checks, the alarms in those test environments need to stay green. So another category around safe deployments that we found is around deploying incrementally. Better to like kind of dip your toe in the water rather than just jumping in. So this gradual deployment we found can really reduce that customer impact. So we start by deploying to what we call one box. It's not necessarily one host or server, it's just kind of what we call it, where it takes a tiny amount of traffic. Oftentimes it doesn't take any customer traffic at first, it just takes our test traffic, and then we put a fraction of customers or a fraction of requests per customer onto this thing. And then we kind of promote that to a whole availability zone in one region, and then like expand it from there. So this incremental deployment we find is really useful. Because we could all, like, if you take it back to that kind of what is the customer impact in this kind of retrospective that we write, we can either say, well, we made a mistake and we got through all those pre-checks and this is why we're going to prevent that, and it caused 100% impact. We could either say that, or we could say, yeah, it caused like less than 1% impact. And so I think we all agree that having any impact is bad, but we can also probably all agree that less than 1% impact is better than 100. So this is why we're so careful, and we make sure we do this when we make configuration changes, any kind of deployment, that we do it incrementally. And then that incrementalness also spans when we go from one AWS region to another. We don't start deployments to more than one region at a time, for example. So gradual rollouts. Another practice that we find is that we need to be able to roll back quickly without hesitation, without anybody even needing to think about that. And kind of this automated deployments made us think a little differently about that. Because before, people would kind of, when people were deploying manually, we might get caught up with, okay, I see this alarm went off, but I think that's unrelated to my change, so I don't think I need to roll back this deployment because that would be an inconvenience. No, it just rolls back in any situation. If any alarm goes off anywhere, just roll back. And so in order to do that, we need to measure from everywhere. We need to have really good observability that measures our systems from a whole bunch of perspectives. Like, for example, we might deploy some change like that only affects some customers in a certain way because it was some weird wire protocol change that broke some old out-of-date client or something like that. So we need to make sure we're measuring from a lot of different places. We can't just look at the one system that we're changing. And then we can aggregate those signals together and roll back if any of them go into alarm. And that's really, we should have that anyway. Like that's, so we need this, the one interesting thing is that we have this anyway for just operating the service. We measure from all these different places. The key is to tie that in and roll back automatically without anybody making a decision if anything goes off. Just because maybe it's a problem, who knows? Let's just roll back first and then figure it out later. Maybe it was just something else. So we can just push it through, it's easy. So in summary, a whole bunch of different categories. I didn't go into every little thing. I hope that some of these kind of sound like, oh, this seems like a good practice that we already follow or that we could enhance our release processes with. Just roll things out incrementally, pre-checks, roll back, and make sure you have really good observability in order to roll back automatically. So next, there's a sort of like similar type of thing we do, that's code deployments. We also change our infrastructure. And so this is sort of a variation on the theme of how can we deploy change our infrastructure carefully. And this is about how I've, in the past, had to make load balancer changes in production over time manually. So the Amazon.com web server fleet, again, is sort of pretty standard architecture. You all kind of make requests through a load balancer, and then we have web servers behind it. But at the end of the day, a load balancer has some maximum capacity. It's a server of sorts. And so as you all grow and we have more requests coming from you, we need to add more capacity. So we just do that by creating a new one, a new whole stack of load balancer, maybe new servers behind it, and then we balance the traffic, split the traffic between the old one and the new one. Okay, pretty standard, straightforward. But me, as a very careful operator thinking about everything that could go wrong, I'm not just gonna yeet that new load balancer into production. I gotta, be really, okay, no, what do I need to do and verify first? So I have a whole bunch of questions. If you just step back and think about every possible thing that could go wrong, you come up with a pretty good checklist. Okay, did I configure this new thing correctly? Is it the same? Is it configured the same as all the other load balancers? Let's double check that. Does it have its certificates bound to it? And do we have the right monitoring in place for it? All these things the endless list of just checks to make sure that we're not going to mess something up. All these pre-checks. So let's say we go through all those pre-checks and we decide, okay, this is great. I'll do another checklist to actually execute that change and put it into production. And then kind of during or following that, I'll have yet another checklist to make sure that worked out great. For example, okay, I issued the DNS change. Is the load balancer actually getting traffic? If not, then I did something wrong and I need to really worry about what that was. So I do those kind of checks during where, okay, is everything healthy? But also those checks need to look at the overall health too, because again, maybe it's something unrelated to what exactly I did could have caused an issue. Now let's say I'm going through that and I say, okay, is the website healthy still? We're just gonna go check that off there, look at the graphs and oh, it's not. Okay, not great, so let's just, let's roll it back. Just right away, if something happened that's bad around the time when I did the thing, let's just undo that thing. So take DNS, flip it back off, and then we're good. We've mitigated the impact and we can figure out why. And go into that kind of retrospective process. Now, a retrospective process isn't oh, David, why did you issue that command wrong? That's not, actually, we don't name operators in these things. We don't, there's nothing that it's just not focused on oh, why did somebody do that? It's focused on why did we even put some person in a situation where that could happen? And so we're examining that and we realize, okay, well, if those errors are happening, these mistakes, skip steps or misconfigurations happen during the execution of that change, well, let's just actually take people out of the loop and not have people making those changes. Fantastic. So one thing we've gravitated toward a lot is just automating our infrastructure as code. So we might have just a CloudFormation template like this one that represents, okay, I need a load balancer with some servers behind it. Fantastic. Now we have a computer do that kind of mundane thing that's error prone that we might miss a step in or make a mistake or have the wrong steps in the first place. So fantastic. Personally, I prefer the CDK, the Cloud Development Kit, where we programmatically define our infrastructure. All this does is actually generate a CloudFormation template, but in practice, our infrastructure is more complicated than just really easily expressible in a static kind of JSON or YAML file. There's a lot of ifs, and I don't really know how to do that. We have sort of in CloudFormation, you can do all these if statements and conditional logic, and I find it a lot easier to read as a program where conditions are great. So anyway, CDK just eventually turns into CloudFormation anyway, so ultimately CloudFormation is still the thing executing the changes for us, so just the sidebar. But then how do the CloudFormation changes that have checked in the source control get applied? Well, the pipeline system. The same pipeline system as pushes our deployments also can point at CloudFormation for each of those stages and make that change. So same system, same pre-check, same everything that can just flow our infrastructure changes through without having to have humans in the loop. And because we have it all in this one system, we can also examine these infrastructure pipelines for best practices as we learn and as we make mistakes and find things that are better to do. We can just examine all of the infrastructure pipeline company and make them better. So when we're making infrastructure changes, we have a few categories of best practices that we've learned. And so this is the wrong slide. This is deployment safety best practices. Psych, this is actually the same. It's the same thing. The practices that apply to doing deployment safely are actually the same categories as infrastructure changes, because now infrastructure changes are just deployments. So, and even when they weren't deployments, it's just really the same idea. So, but there are some nuances and interesting things to talk about with it, that are a little different or maybe even harder when it comes to infrastructure changes. So let's spend some time going into that. So with deployment safety, Fractional deployments were easy. You could just kind of deploy to one host at a time, whatever. You could make them as incremental as you feel like. But how can we do that with infrastructure changes that are just these big things that we need to move around? Well, let's talk about an easy case first. So let's say we're doing that kind of load balancer change. Well, instead of just in order to put a load balancer into service, we're actually modifying DNS, like Route 53 resolver. And we're saying, and before you call a website, your web browser is asking DNS, hey, where do I go to talk to find out what load balancer should I talk to? Well, Route 53 can return multiple records, and it can also roll a dice to say, some of the time I'll send people here, some of the time I'll send people here. And that dice can be weighted, something that we definitely don't have here. You don't want to have weighted dice. You want to talk about that in Vegas. It would be, but you can weight these dice and favor one load balancer or another, which is super handy when you're putting a new load balancer into service. So instead of putting the new one on the right all the way into service, just put it a little bit into service. Favor the old one quite a bit, and then we can test and make sure and run that pre-check on the new load balancer to make sure that whatever traffic it is getting looks good. So like during this, we can incrementally dial it up. Run this checklist. Okay, dial up to 1%, dial 5%, 25, et cetera. Running all those checks as we go, gradually. So you can do certain infrastructure changes gradually, just like we can deploy gradually. Now, some things are harder. Some infrastructure changes are a little tricky. So let's say this is some web service or website or something where you're all calling some load balancer, and behind that load balancer are a bunch of instances, EC2 instances, and those need to get some data from a DynamoDB table. So just pretty simple architecture. Now, overlaying on top of that, sort of the meta stuff is these instances are running in different availability zones, all managed by one auto-scaling group that kind of decides where to put which instances. And those instances all have an IAM role configured so that they have permissions to talk to that DynamoDB table, the right permissions. So let's say I'm making a change. Let's say I'm implementing a feature in this thing that needs to introduce a new DynamoDB table for some other functionality. Well, I need to be able to define my infrastructure as code, and I'll get that going. Well, my application also needs to be able to talk to that new table. It doesn't have permissions because I'm using least privileges. So in my infrastructure as code file, I have this IAM policy that says allow query on just the one table. That's the old one. Well, I need to make a change to it, so I send out a code review, say, okay, add permission to the new table. And also, I need to modify that previous line because I need to add a comma because JSON. Okay, great, fantastic, that sounds good. So, but what if I accidentally made a different change? Like I made a change where I actually just deleted and removed access to the old table? Well, that would be a problem. So what would that look like? Well, let's say it gets through testing somehow, just for illustrative sakes. So when I actually go and deploy that change, I get that new table created, CloudFormation creates a new table, it updates that role with the new permissions, now my application can access my new table, but it can't access the other table anymore. So that's not great. That's get all at once, just like boom, like no more access to that table, a lot of errors, not great. Okay, so we need a way in that case to deploy incrementally somehow. So how do we do? Well, when we define our infrastructure in the first place, we think, well, how in the future will we be able to safely mutate that infrastructure? And probably having one role shared across the entire service is not going to be, it's going to be really hard to safely, we'll have to be really careful about how we modify that role permissions because of what I just illustrated. So instead what we do is we define our infrastructure, our logical infrastructure, to be separate. So we can change one, and then the other, and then the other. It doesn't have to be 100. It could be, say, 3. We like to actually, and I didn't picture here is like a one-box environment. The one box would even have like its own auto-scaling group and role and everything, too. So we could test it there before we even start with deploying it to anything. And so we actually also like to align our logical infrastructure pictured here with the physical infrastructure of availability zones. And that's really convenient because we've already written all of this like automatic failure detection and fail out to handle physical failures that we just know are going to happen and we do game days about. But by making our logical infrastructure match up with that, well, now all those things that we've done can just apply to any type of failure, whether it's a logical infrastructure failure or a physical failure. So it's a convenient thing because now, whenever we do that update, we're just updating it to a subset And yeah, that one breaks, it can't talk to the table anymore, and now we can just get the traffic off of that. We don't even technically need to roll that back to mitigate impact, we just need the traffic to get off, which can even happen automatically. So there's another type of infrastructure change that we do, and we need to be able to do pre-checks, just like in deployments. Now, let's say instead of just balancing, we're actually starting to migrate traffic from one load balancer to another. Maybe we need to decommission the old one and get rid of it for some reason. Well, similar situation, create a new one, migrate the traffic over, now remove the traffic from the old one, and decommission that old load balancer and all the servers behind it. Great, easy to do. So what happens if we were to do that kind of wrong, though? Like, what if we actually don't do those steps in the right order and we accidentally decommission the load balancer when there's still stuff pointing to it? Well, that'd be bad, because now all the things that we're trying to talk to it can no longer talk to it. And so, in the distance, the pager goes off, and another. So not great. And actually, this type of thing can happen. Now, if this were to happen with DNS health checks would take that out of service within a minute, whatever, anyway. So this is sort of a bad example, but this type of thing does happen. When I started at Amazon, my first month at Amazon, I remember I worked on Amazon.com on the web server fleet, and I remember just working and somebody's pager went off in the distance and then another one. And then the person next to me, at the desk next to me, just was like, oh, shoot, and got on the phone and was like, this was me. Like, I just realized I was turning off I was decommissioning a test environment, and I accidentally decommissioned Amazon.ca, the Canada production environment. Yeah, it's like, but again, like nobody was like, oh, why'd you do that? They were like, oh, wow, we should not make that possible, and we should also just be able to decommission these test environments automatically in a different way, and so all this stuff. So how do we get those guardrails? Like, decommissioning is super hard. Well, we need those pre-checks, especially even as infrastructure as code type stuff. So how do we get these pre-checks in there? There are a lot of really useful ones, especially before a delete. Are you sure? Is this actually what you want to do? Is it in use? This is a really interesting pre-check. If I'm manually being as careful as possible because I know it's production, I would be like, oh, I'm not going to delete these instances because they are at 80% CPU, 60% CPU, something, right? That's probably a sign that I'm doing something useful, maybe. But it's a good thing to be considering, and by default, just not make progress. So how do we make our automation be as careful as I might be and pessimistic as I might be if I were doing this by hand? Well, CloudFormation, for example, has some things like this in it, and other services too that I'll kind of highlight. There's termination protection for CloudFormation. So you can say, even if you try to delete your CloudFormation stack, it just won't let you. You kind of turn two keys at the same time kind of thing. The key is that when you do the automation around CloudFormation is to not turn both keys automatically. So it's just an extra pre-check. There's deletion policy in CloudFormation to say, even if the stack is deleted, leave the database. I'll deal with that later, I don't want to even try to mess with that as a part of this automation. Something like that. More features like termination protection in EC2, and you can even write a policy that says deny the thing that's making changes the ability to delete the database, the table, whatever, the thing that I really care about. Now, we shouldn't have granted anybody the ability to do that thing because of principle of least privileges, but you might sleep a little better at night if you have that as your belt and then this as the suspenders and a pocket protector as well or something. So it's just an extra thing that's just an extra safe. Now, there's this other type of pre-check that we have too that's really interesting. There's a newer type that are kind of a little bit more DIY, programmatic type things. CloudFormation has change sets. So you can ask CloudFormation, instead of just, hey, apply this change, you can say, hey, CloudFormation, what exactly would you change if you were to do this? Because we entrust CloudFormation to do the right things to get from here to there, but we don't necessarily know exactly what that is. So we can ask it, okay, what would you do to get from here to there? And then you can programmatically look at it and say, in the pipelines tool, and say, oh, this change, I'd never want to be doing that unless I'm really sure about it. So just by default, I won't allow it to delete a role along the way to creating a new one, something like that. So just to avoid surprising changes, you can programmatically audit the change sets. Another really a newer one from this year is CloudFormation added these hooks. So when CloudFormation is updating your stack, it can invoke at different points your own logic, your own Lambda function, and you can check things. It'll say, hey, I'm about to descale this auto-scaling group to 0. You could write a Lambda function that checks the CPU metrics or number of requests going to that auto-scaling group. And if there are any, don't let CloudFormation do that. So I'm just really excited about like what we can do and what I've seen people start to do with CloudFormation hooks. I think it just adds this whole level of safety to automated infrastructure as code changes. I'm just really excited about it. Oh yeah, you can look at, imagine sky's the limit with what you audit too. You could say, before I delete a role or a credential, like check CloudTrail logs to see if it's in use. I think you can query an IAM API anyway too. So all these like in-use checks before deleting things, pretty neat. That was one last type of infrastructure change practice that we do safely, and that's on rollback. It's actually about deletes again. So how do you roll back a delete? Like it's really important. We found it important for code deployments to just roll back immediately. How do you roll back if you deleted something? A little harder. Hopefully we've taken backups and everything so that we can restore and that we have tested to make sure that we can restore in practice quickly. That's like important to think about. But one way that we can roll back, like if you're putting your hat on that says like, how am I going to do this as safely as possible? Like before you like turn something off, you can just make it so that nothing can talk to it. Like before terminating an EC2 instance, network isolate it. Because then to the rest of the system, it doesn't exist. They can't talk to it. And so if any of these like alarms go off, well, then you can roll back the delete. You just restore access to it. So you can think about this type of thing, and you can do that with IAM policy. You can deny access to a resource, and then for all intents and purposes, it doesn't exist. Nothing can talk to it. So that's one. It doesn't, of course, catch everything if something isn't always in use and being called, and if your alarms are wrong, but it's just another one of these pocket protector, belt suspender things that you can do. So when deleting, just we think about that very carefully. So infrastructure change safety practices look a whole lot like deployment safety best practices. They're just a little bit harder.
But there's one more kind of change that things get really, really hard. So at AWS, since the very beginning, we've treated every service we launch, every feature we have, every API as a promise, right? We know that customers are going to build their businesses on top of those API calls, and we can't just take them away, right? We can't just go breaking them. And it's exceptionally rare that we turn things off. And some simple examples of that, we still support the original SOAP and WSDL APIs that our very first services launched with in 2006. Those are still working. Not very many people building against those APIs. Or S3 added BitTorrent support in 2008, and that still works in the regions it was supported in. And when's the last time you ever heard about BitTorrent, right? But it's still there just in case. But sometimes, things come up where we do have to make a backwards incompatible change. Typically, any change like that goes through a lot of review. We actually have to review them with the AWS leadership team. Hey, we got to make a breaking change here. Triggers all sorts of processes that go right to the top. And those changes are then shepherded and stewarded by an executive sponsor or a senior leader who's going to really pay attention that we're doing this the right way throughout the whole process. And these can be very long-running, intensive operations, and it's become a very key part of how we operate our systems. One example of this is EC2 instances became so popular that we actually were in danger of overflowing the original 31-bit ID field for instance IDs, and so we had to make it longer, which is a change in the API, right? And some customers' code would have to get updated to use a long int instead of an int, and so on. The SSL and TLS protocols have changed over time, right? We launched in 2006 when SSL v3 was still relatively common to see being used. Whereas, these days, compliance frameworks and regulators you have to turn SSL v3 off or you won't get a certain compliance standard that, a lot of our customers need. And the same for, TLS1 and TLS11 and encryption algorithms that have been deprecated over time. And the way we work on these is it is a process of adding instrumentation and making sure that we can identify everyone who could be impacted by this, building data and observability into our systems at whatever level it takes, so that we can either determine, well, we've got things to a state where there's not going to be any impact, like maybe all the clients have been updated, so it's going to be okay, or we know who's going to be impacted, and we can work with them on a case-by-case basis and give them the information they need, hopefully in the form of actionable notifications that tells them, hey, we're still seeing this API call in that's going to be turned off in X months or years, or this SSL version and so on. And you may have noticed features like this we've rolled out across a lot of services. ELB, CloudFront, API Gateway, they all log the SSL versions so that customers can be empowered to make sure that they're going to be able to stay compliant. These days they need things like the organization ID, so this all can be done at organizational level too. And not just that, we don't just instrument it and say, okay, well, we told you the deadline, have at it, it's on you. We really do manage it case by case and look and actively pursue it and go, well, if we're seeing a certain customer still using it, reach out to their account team or find some contact details for them and literally talk to them if that's what it takes. But then even beyond that, even when we think everybody's on a good track, we don't think there's going to be any impact, we don't just let it get to the deadline and turn it off. We actually do a fake out. So we turn it off for a few hours, enough to cause someone to notice if they do happen to still be using it, but then we turn it back on, right? So that if they were impacted, well, now they know they can be impacted by this, but at least service was restored, and then they've got a bit of a buffer before the real deadline that we can't do anything about comes in. And every time we run this process, we use it to try to learn as much about our systems as we possibly can to improve this for the next time. And one of the reasons, besides kind of conveying, just how much detail and depth has to go in to understanding systems and instrumenting systems, one reason that I wanted to tell that story is I think we've been doing DevOps for a long time at Amazon. As developers, we build our services and we also operate them, we run them. And a lot of people think the number one benefit of DevOps is, okay, well, the developers now have a lot of skin in the game. They're going to write better systems because, they're on the hook if anything breaks. And that's true. That is a big benefit. But I think over time, I've learned to appreciate a bigger benefit is actually understanding how our systems are actually being used is really, really critical to building better systems, right? Because patterns of access and usage and requirements all change over time. And those can impact, what the architecture should be, or, what a certain database index should be, or how to optimize a certain thing. Those all can be data dependent and usage dependent factors, right? And so when we run these processes and they're owned by the teams who have to run the systems, it gives us this really strong sense of, oh, this is why we support APIs, so long, because we see how painful it would be to just turn things off, right? Or this is why we instrument things so deeply, because we know someone's going to have to take an action based on this. Or this is why we instrument things, because it gives us so much information about the shape and nature of the usage patterns, so we build that into optimizations for the next version. As David mentioned, we've got lots of more articles with lots more detail in the Amazon Builders Library about all sorts of classic operational excellence lessons. Every article is written firsthand by a practitioner, an engineer who worked on an AWS service. And they're just rich gold mine. On behalf of both of us, thank you all for coming. It's been a real privilege to talk to a room full of builders, and hopefully you enjoyed the talk. Thank you.